Okay, so let's now start into right triangle trigonometry. So before we continue on with this part, I do want to come back to the previous history of where trig functions come from and just return to this visual that we have here of the bow. And it was the bowstring which kind of inspired maybe the relationships with trig functions. And, part of the reason is that if you look at the bowstring when the bow is not in use, and then when you knock an arrow in the bowstring and you pull the arrow back, then you've got two sides of a right triangle. So we have this side of a triangle and we have this side of a triangle, and there's a 90-degree angle between the two of them. Another word for a right angle is a 90-degree angle. And so between these two sides, you have this diagonal line kind of connecting the ends of both sides, and that is the hypotenuse. So maybe keep this image of this right triangle inside of this circle, which will be the unit circle, and the terminal side of our angle of interest is the hypotenuse. All right, so let's go to the definition of right triangle trigonometry. So a right triangle uh, is a triangle with one 90-degree angle, symbolized with a square in the corner. Okay, so in these illustrations down here, these squares in the corner represent 90-degree angles. The right triangle side opposite the 90-degree angle is the longest side, called the hypotenuse. So the side that is opposite the right angle, the side that is opposite the right angle, the side that is opposite the right angle is called the hypotenuse. Now, the Greek letter theta, which kind of looks like an O with a horizontal line through it, is used to label the angle of interest. The right triangle side that is opposite the angle of interest is called the opposite side. So here's our angle of interest. The side opposite it we call the opposite side. Angle of interest, opposite side, angle of interest, opposite side. Choose a different color here. There we go. In a right triangle, the side adjacent to the angle of interest is called the adjacent side. So here's the angle of interest, and here's the side adjacent to it. Adjacent is another word of saying next to. Angle of interest, adjacent side. Angle of interest, adjacent side. So as the angle of interest changes, and we keep the hypotenuse held constant, the shape of the right triangle changes, and the length of the opposite and the adjacent sides of a right triangle will change. And the ratio of one side of the triangle with another side will also change. So let me kind of erase these marks. There we go. All right. So if we look at this first example, we have a right triangle, ABC. We have an angle of interest. And if we look at the side opposite our angle of interest, that is the opposite side, and the opposite side has a vertical orientation. So that's in the same direction as the y-axis. Okay, and the side adjacent to our angle of interest, that is on the x-axis. Now, this particular triangle, triangle ABC, this is an angle of 45 degrees or pi over 4 radians. And what you'll notice is that the length of segment BC, so this segment, is also the same length as segment AC. These are both the same length. And what I mentioned earlier is the side of the triangle that is opposite this right angle, that's the hypotenuse. So side AB is the hypotenuse. Now, what I mentioned earlier is that when this angle changes, this angle of interest, the length of the sides will change. So let's look at the next triangle ABC when the angle of interest is less than 45 degrees. And you can see here with this angle being less than 45 degrees, the opposite side gets shorter, and relatively, the adjacent side gets longer. When the angle of interest is greater than 45 degrees, so when this angle is greater than 45 degrees, the opposite side gets longer and the adjacent side gets shorter. So that's where I mentioned earlier that as the angle of interest changes and the hypotenuse is held constant, the length of the opposite and the adjacent sides will change. And it's these changes and these sides that we've labeled opposite, adjacent, and hypotenuse that form the basic definition of these trig functions. So we can see that the sine of an angle of interest, so the sine of our angle of interest is a ratio between the length of the opposite side and the hypotenuse. So if we come up here, let me erase this. So we would say that the sine of this angle is a ratio of the length of this opposite side over the length of the side of the hypotenuse. And another way of saying that would be the value of y, the y value going up over the radius, because this forms the radius of a circle, like that. So this would be the radius. Cosine of an angle of interest, I'm sorry about that. A cosine of our angle of interest is the ratio of the length of the adjacent side over the hypotenuse. All right, so here is our angle of interest. The cosine of this angle is the ratio of the length of this side, the adjacent side, to the hypotenuse, or x over r. And the tangent of an angle of interest is a ratio of the opposite side over the adjacent side. or y over x. So the tangent of our angle of interest is a ratio of the opposite side over the adjacent side. So it can be helpful to remember these by looking at the first letter of the trig function, which is s, and then the first letter of the sides that compose it. So we have sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And if you haven't heard this before, this is where SOHCAHTOA comes from. So you have sine is opposite over hypotenuse, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, opposite over adjacent. So that's where the acronym SOHCAHTOA comes from. That's a helpful one to remember. Now those constitute the core three trig functions. But there are three others. So there's a total of six. So those other ones are cosecant of an angle of interest, the secant of an angle of interest, and the cotangent of an angle of interest. These are reciprocals of sine, cosine, and tangent, respectively. So let's look at sine, for example. So we have sine, and sine is opposite over hypotenuse. Now, a reciprocal is if you switch numerator and denominator. So if you switch these around, you now have r over y. And if you switch opposite on the hypotenuse is on top, the opposite is on the bottom, and that's what cosecant is. So sine theta and cosecant theta, these are reciprocals of each other. Okay, let me use some darker coloration here. So cosecant and sine, these are reciprocals of each other. Likewise, get rid of some of this stuff. Okay. Likewise, cosecant and secant, these are reciprocals of each other. And tangent with cotangent, those are reciprocals of each other. So you can write, the reciprocal, as switching hypotenuse and opposite sides. You can switch, r, x, and y. Or you could think of cosecant being the reciprocal of sine by thinking of cosecant being equal to 1 over sine. Secant as 1 over cosine. And cotangent as 1 over tangent. All right. So these will be concepts that you will become very familiar with because you're going to be using these facts over and over and over again in solving problems and finding solutions. And finally, there's an interesting thing to notice, particularly about tangent. So let me clear all this away. So the tangent of an angle of interest is equal to y over x. What does that remind you of? Does that remind you of rise over run? A rise is a change in y values, and the run is a change in x values. And what was that? That is the slope of a line. So when you take the tangent of an angle of interest, you're actually getting the slope of the hypotenuse itself. So that's what I have down here. Tangent of an angle gives you the slope of the hypotenuse. Okay, so that's enough of an introduction to right triangle trigonometry. Next, we'll look at some examples to help kind of bake this in.